Welcome, everyone. This is Juan Soto, Microsoft Access MVP, founder of AccessUserGroups.org, and you have joined the SQL Server with Access meeting that we have every second Tuesday of the month. If you're watching this on YouTube, we wish you have seen this live. We always appreciate the live audience. Please consider joining us next month. We meet every second Tuesday of the month. You'll see our group as well as all the other groups who have events throughout the month at AccessUserGroups.org/calendar. Today we have one special host with us, Roy Kim. He is an Azure MVP, a good friend of mine, and we worked on multiple projects together. Roy, how are you?
Great. How are you, Juan? How's
Good, good.
everybody?
I am really delighted to have you here because Roy and I worked on a very large project recently, and because of that project, I told him to come and present and talk to us about the technology he used and the approach he took. Roy, why don't you tell us a little bit about the project before we get down into the nitty-gritty details?
Oh, yeah, sure. Yeah, the project was working with a tape device for packaging, right? On conveyor belts, and they have a sensor that measures how much tape is used, if the tape is run out, if there's errors with taping the boxes and such. So, they wanted to collect that data and telemetry real time, right? So that they can build a dashboard, a reporting dashboard, so they can, make actionable insights and monitor the system. And it's for their customers.
Yeah, so Roy's been a little bit humble. This is a worldwide platform that's going to eventually cover all the factories that they supply tape to. We're talking about hundreds of thousands of endpoints. And it's funny because when they originally reached out to us, Roy and I were from the beginning designing the platform, and he mostly Roy. What it is, they use cell phone modems at each factory to gather the data, and that goes up to Azure. But the customer says, "Oh, we want you to configure this to handle 100,000 endpoints." I'm like, "Why? You haven't gotten any yet, right? Why spend all that money and all those resources?" But they were adamant. Says, "No, we want it all set up because we're gonna go gangbusters on this." I'm like, "Okay, let's do that. We'll do that for you." I mean, we try to save you some money, right? But these kind of endeavors are a really good way to be able to collect data. And they use cell phone modems because they didn't want to interfere with the Wi-Fi network of the local factory, right, Roy?
Yes, exactly.
So they go in there, they put a cell phone modem gateway, which Roy helped to select one, and then we tested initially. And then all the other machines in the factory are transmitting data to that cell phone modem via a local Wi-Fi network, and that gets uploaded. So Roy, why don't you take it away and let's do the
Sure.
presentation.
Okay, awesome. Let me share my screen here. So, for all you guys, thanks for joining. Please feel free to come off mute, raise your hand, if you have any questions, because you're here live, so you take the opportunity, the advantage of, asking away and interrupt and have a dialogue. I'm here for you. Okay, it's not for me. You know. All
Hey
right.
Roy, we're
So
getting a lot of interference on your end. I don't know if anybody else can hear that. All
I
right,
don't
went
think it's
away. Go ahead, keep
okay.
going.
Okay, I don't think it's me. All right. So this is about data ingestion. Okay, pipeline from Azure IoT Hub. Okay. So again, key thing here is, I'm from Toronto. Feel free to check out my blog, and I love it if you can subscribe to my YouTube channel. I'm posting a lot of videos. All right. So what's this whole IoT Internet of Things and all that? So I took this slide from the Microsoft website, okay, the IoT documentation. So just very high level, we have IoT cloud services, okay, which I'll really get into, and it's all about, real-time data streaming, okay? So we're getting like tons of messages per second, and to be able to process that data, to receive that data, process it, from multiple devices, okay, and message enrichment, message routing, okay, routing to one message queue to another queue to be very scalable. okay, and also to do, data translation, right? So parsing the data, splitting the data, date, time, transformations, dealing with like time zones and things like that. Okay. Um, taking JSON data and to make it into SQL database. So at the end goal is to do a further analysis, store it into a database, Azure storage, and then to do visualization. Okay, so of course, this data can also land into Access database. Why not, right? And to do reporting on it, etc. Okay. So we're the whole idea is to receive data at a very high rate, okay, process that, and then do analytics and to store it, and and typically it's to a report, okay. But we still got to take into mind scalability, error handling. What if something goes down, a component in here, can it pick it back up? It has to be robust, all these factors. Okay, and that's kind of what we had to deal with. Now on the left side are our devices. Okay, so there are many devices in the market, and then there are many protocols on how to reliably send messages, and it all varies because sometimes these devices are going through the internet, sometimes going through Bluetooth to a gateway or Wi-Fi cellular, as Juan mentioned. That was Wi-Fi, to the internet. And so there's various ways, right? So, and also the devices themselves. Okay, a lot of the times they need to be low power because they're out in remote areas like a field or across a factory, and they don't have like direct power, okay, and they're maybe battery powered for whatever reason. So the data and the data payloads, they have to be very light, okay. So that's one requirement or one thing we see, okay, and the reliable messaging. So I'll get into that a bit, but just keep in mind that there's many devices out there, and the way they communicate and send the data is pretty varied, right? And so you have like very much embedded software. So that's kind of the high level of kind of what the IoT platform looks like. So I just want to pause here. Does anyone have any questions? No? Okay, cool. So what are some, like, at the end of the day, we're as technologists, we're here just to serve the business, okay? And users. Okay, so what are some typical use cases, right? So a lot of the times it's manufacturing, real-time asset monitoring, predictive maintenance. So like HVAC system, maybe there's a certain pattern where where they're looking for a certain pattern where it may things need to be repaired. Okay, like an HVAC system, like during winter, or cooling system during the summer, and there's various factors that they can detect patterns, and then to raise that in real time, that's where IoT could come into place. And also, as Juan was talking about, the project is real time monitoring on, let's say, some kind of conveyor belt or a packaging machine, and really to have a sensor on the tape head, right? So just, your standard, like if you go Amazon, there's always a wound of tape, so, adhesive tape on it, and how much tape is being used. Is it running out? Are there errors in the taping machine? So, how do we monitor that, real time, and be proactive or reactive very quickly? Okay. So again, agriculture, farming, livestock monitoring, irrigation, crop health, depending on the devices that help sensor that. Okay, energy, smart grids, real-time consumption, etc. So I think you guys get the pattern. Wherever it can detect data, and they're collecting it, abundance of it, and they need to send it out real time. This is where the IoT platform comes into place and be able to, in a scalable and robust fashion, ingest it and then and process that data and then store it into, let's say, a database. Okay, so here's is a IoT reference architecture. Okay, and I'll walk you through this, and then I will also show you implementation details through the Azure portal. Okay, so we have here on the very left a factory site, multiple taping machines and things like that, sensors, and there's usually a gateway on that site. Okay, and and of course, it's like that hub, it's that gateway that's collecting all that data and then sending it out to the IoT hub. So typically the IoT hub it's internet facing, okay, needs a public IP address, okay, that's static. And it could be through your corporate internet with outbound to the internet, or as Juan mentioned, Wi-Fi cellular, so that this gateway doesn't need to bother with corporate network. Okay, so it goes out to the cloud. And of course, this line right here, there has to be some kind of security, access security. So in this case, it was some kind of SAS token, just a fancy password. Okay, in simplest terms, you can do stronger authentication and with certificates like private and public key pairs, etc. So we have this IoT hub that takes in the data, and the next step is some kind of event hub. An event hub is a message queue, okay? And think of it as like a five lane highway, okay? And each car is a message, okay? And in that highway, you can queue up data. And let's say that if IoT Hub goes down, and or let's say if IoT okay, let's say Stream Analytics go down, like the receiving of this data or the reading of this data, then it can still continue on. Okay, and also Event Hub is behind the scenes is designed to be pretty scalable too. So if you're taking in a very like extremely high amount of data, so it's advertised as taking 1 million messages a second. Okay, so as long as you have a lot of these highway lanes like partitions, okay, you can have like several 10, 15, and they could all be ingested all at once, and able to scale in that horizontally that way. That's what the function of the Event Hub is. Okay, so it's just a message queue. I have here something called managed identity. So each one of these services have something called identity. So basically, it's just saying that how does this service authenticate and get permissions to send data to the Event Hub? Okay, because we don't want this to be pretty open. So it's giving some layer of access security. Okay. Of course, we have something called a virtual network, so that traffic can go through a private network. Okay, so each one of these would have something called a private endpoint. It would flow through that. Okay, so this is an option, right? If you wanted to have more network security. So each one of these have a managed endpoint that says, for Stream Analytics, say, hey, I allow permissions through this managed identity, which is associated to the Event Hub, to write to the Stream Analytics. And the same thing with the database recognizes this managed identity, right? So in old like Windows terms, it's like a service account. Okay. We also have so Stream Analytics is where we process the data. So it comes out as a JSON format, And you may think, well, okay, the data's format is all nested. It's got, a lot of like columns or columnar data, has a lot of nested data. So it's able to parse it out and flatten it out, ignore some details in the data, etc. Okay, and take whatever you want. And then sometimes you need to work with the dates to do some date translations, etc. So this is where a lot of compute power potentially needs to occur to process that data and to put it into a format that the database can ingest, right? That can be written to the database. Also, you can route the data to something called Azure Data Lake Storage, which is a just a general, in simple terms, just a general file system, very scalable. So if you can put the raw data into the data lake storage, and you can put some of the processed data right to the data lake storage in more like raw format, like CSV or JSON. So you can, either put it for safekeeping, for archival, for troubleshooting, for debugging that you want to go back and say, okay, we want to trace, okay, what happened? Something didn't go well with the data processing, or we need to read from here, replay that data, and then put the correct logic and then put it back into the database. So here it's, what do you call a cold path. The data is cheap to store but very scalable. Whereas in the database, of course, there's a lot of cost to storing into Azure SQL. And of course, you can always go with other types of databases like Cosmos DB, Postgres, MySQL, etc. Okay. So once the data is all refined, okay, and it's more of in a business friendly format for reporting, next you would have some kind of reporting application, right? So you can do Power BI, connect into Power BI. In this case, there was a custom web application. It was a custom reporting, right? Using JavaScript libraries for custom reports, right? And because this report was more internet facing to a wide array of customers, they will come in and to read that reporting database. Okay, so that's the end-to-end flow. Okay. And of course, we have, general monitoring, cost management, monitoring dashboards, etc. So let me pause here to see if anybody has questions about this architecture, how things flow.
Right now, there is no questions, but if anybody has a question, they can unmute themselves.
Mm-hmm.
Now's your chance.
Okay. Okay, cool. Moving on. So let's talk about the device side of things, right? Because again, it's really varied. Okay, but the one thing I want to take away here is that, there's many IoT compatible devices and protocols in the market. Okay, and one type of protocol is LoRaWAN. Okay, and that's kind of what Juan mentioned in the project is that LoRaWAN is a long-range, wide area network protocol. Okay, it's for low power, wide area, long range. Okay, low bit rate that's connected to devices and sensors. Okay, and can be operated on a battery. Okay, so that is one specification. Okay, and of course, out there, power may not be a big deal. It could be short range, network, etc. So again, as I mentioned, agriculture, energy, factories, there is a wide array of physical scenarios, and that's why there's a lot of devices out in the market there. But these are the type of devices, right? Just to show. And then you have a gateway and connected to each individual device. Okay, and so the sensors themselves typically would have like embedded software like C or C++ or maybe Python or something very lightweight and probably be like embedded kind of a Linux and then to be able to just collect the messages and then send them over to the gateway. And then it's the gateway that you configure that connects to IoT Hub. Okay. So the LoRaWAN uses a protocol called MQTT. So that's a pretty popular protocol to connect your gateways and devices. So what is this MQTT protocol? It's called Message Queuing Telemetry Transport. It's lightweight, publish and subscribe network to send messages. Okay, low bandwidth, high latency environments. Okay, and it's reliable and efficient and has different levels of quality service and has security features to have SSL, TLS for secure data transmission, and IoT Hub can be that MQTT broker. And then there's concepts of, let's say, in IoT Hub to register that device and to monitor and to receive that data. Okay, so let me switch over to a demo. Okay, so right here I have just like a representing a device or a gateway that's sending randomized data here. Okay, so I had it running for a bit. Okay, just for a demonstration, and really it's using the software development kit for IoT Hub, and it is just generating the data. Okay, that's what it looks like. It's generating the data. It has the connection string, okay, with a API kind of key to securely connect into the IoT Hub. So it's running in a loop and it is sending data over. Okay, so to give you an idea, this is what the data looks like. So you have like some kind of application ID, application name, device identifier, representing that device, and then also the timestamp. So whatever date and time it is right now, it is sending that over. Some of this data is pretty static, data encode, etc. Okay, and then you have some nested data. Okay, like gateway, also maybe either the location data you would have, right? Latitude, longitude. Okay, and then you take that in there and then you send it over. So in this case, it's a JSON format and that gets sent over. See here, is there anything? So yeah, that's the that's how the data looks like and it's being sent over. Um, so just stopping right here, all that data. Okay. Okay. So moving on. Okay. So right here in the Azure portal is your IoT Hub, is certain standard pricing tiers. This is the host name. Okay. Here we have the devices that are registered. Okay, so you have to register each device. So this is the that code that's running, and so this is registered and recognized. Okay, and here you have like the primary key, which is like the password that's part of the connection string, right? So this is the connection string that you're connecting into this IoT Hub. Okay, just for that application. So that's one key configuration that needs to happen. Okay, configuration setting. And then one key thing is the message routing. Okay, so we want to route it to what we call that event hub, which is a message queue. And so I had it configured here, and it is endpoint. This endpoint is referencing that Azure Event Hub, which I will talk in a moment. Okay. Here you can do some routing query. Here it says true, which means whatever messages I get, just send it to this endpoint, this event hub. You could do rules such that, what, if that message has message dot color equals red, okay, then, if that is true, then you send it to this endpoint. So that's how you can kind of route it, right? And then you can have another route that says if blue, then you create a different endpoint, going to a different event hub, or in this case, you can see here, you can directly store it to Azure Storage Container, Cosmos Database, and other service bus queues and topics. Okay, so you have that flexibility. Okay, and then here we have the custom endpoint where it is pointing to that IoT event hub right here. Okay, and all these data such as retention of the data, etc. Okay, so those are the key things. I don't want to bore you with other details, but those are the key things. I'm using standard tier, 400,000 daily messages limit. So this IoT tip is not that overall. It's not that pricey in the grand scheme of things. Okay, because it's just passing messages. Okay, so next we'll talk about
Hey, Roy,
the, yeah,
here's a quick question here from George
sure,
Hepworth.
yeah, go ahead, yeah, please.
Yeah. Given the large amount of devices that you'll be installing in the factory, potentially dozens of devices across multiple factories, you're looking at thousands of devices. How do you manually get that device associated with that gateway and recognized by the Azure network?
So repeat the how do, was
For
repeat
example,
the
I got a new tape machine. I got to slap a device on there, not the gateway, but the device actually measures issues.
yeah.
How do I register that device with Azure to accept data?
Okay, so so you're actually registering the gateway, okay? So you have to register that sensor, that device, to make sure that it sends it to the gateway, or well, or in this case, the LoRaWAN gateway, okay? So in at the end of the day, you are registering the gateway.
Okay, so I plug in the gateway. I get that, right? But
Yeah.
what about the individual devices on the machine? They are not gateways. How do I configure those?
You configure it against the gateway,
Oh, okay, all right. So I'm going in the
right?
gateway with my laptop, and I connect to the Wi-Fi network, and I know the password, and then I can
Right. Yeah, and
authenticate it. Okay.
there are some cases where even though it's connected to the gateway, because the device themselves have like a unique identifier, there are cases where you can register those devices to be recognized as a device itself, right? So if you go to devices here, and then even though there is a gateway that's brokering that, you can, add the device, put the device ID, and uh, configure as such, right?
Okay.
Um, well, yeah.
Thank
Okay.
you.
Hopefully that answered your question. So
Yeah, thank you.
if anyone has other questions, feel free to, yeah, bring them forward. Glad to answer. All right. So next, what we have here is I want to like put this slide here. Okay, so we talked about the IoT Hub. Okay, next we're talking about the Event Hub. Okay, so it's passing here, and this is the message queue. Okay, actually, before I do that, if we go to the IoT Hub overview, okay, we can see some monitoring here. So here, just at 7:30, I started that app. Okay, and then we can see the number of messages that have passed through. So just in the last, like half hour, okay, we had close to 9,000 messages right here. Okay, and one IoT device, which is that app. Okay, and then we can see that some other metrics right here. So going to the Event Hub, here we see that as well. Okay, and so here it is queuing in. Okay, so we're showing data for last hour. So I mostly pay attention to this part right here where we see, again, the timing is 7:32. The messages start piling in here and get queued up. And we can see here the throughput, right? So here, it's this is, really scalable Event Hub. Okay. So it's just a simple pass through. We're not processing any data. So one thing about the Event Hub, okay, is that if we're to have multiple readers, okay, of the Event Hub, whoops, okay, if we're to have multiple readers, like it could be streamed analytics jobs, it can be another application using the Event Hub API, and we can read that data. So it could read them. There's many variations of reading the data. Okay. But here it's a pretty straightforward pass through, and it's just there to monitor kind of the message flow, the throughput, etc. Here the requests, it really means each request against the Event Hub to, either write to the data or send it. So they're more like application calls. That's how I see it as. Okay. And so really the stream analytics job is making a request to pull out that data. So even though data is read, it doesn't mean it's deleted because there is a certain retention, okay, schedule, maybe like 7 days or what have you. See here, there is for debugging, there is this position. We can view the events, okay? So here, this is the data. So sequence number, that's dictated by the Event Hub and the offset in the queue. When it entered the queue, okay, what kind of content type? And then here is the actual JSON of application body here. I know we can't really see it all. Oh, okay, here we go. So event body. Okay, so one second. So event body, device name, port, machine ID, some nested records, the time. This is the time at the device, like a timestamp, the time at the device. And then we have, units like no tape, what the value is, maybe the actual machine ID of the sensor, whatever. There's tons of amount inches, and the value of that is 28.9 inches, etc. We can go on and on and on. So it has that data. We can view it, right, as it comes in. We can say, sometimes for troubleshooting, we have that sequence number or a certain time range that we want to look at. So that's where in Event Hub we have that ability to troubleshoot and see what's going on. All right. So now is okay, you get all this data, look at, and it's like, very complicated, right? How do we process that? How do we pick at what we want and put it in a format that is more business friendly for reporting, okay, into our SQL database? So that's the next question. And that's where we get into the stream analytics job, okay? So I come here and we can see here that the resource utilization, okay, it's running at, 25% because it's processing all that data. The number of events, okay, the way I see this is like each message, okay, that's coming through. Hold on, is this monitoring the last hour? Let's see here. Oh yeah, it's the last hour. Okay. So let me do that again here. So 30 minutes. Okay, I think just refreshing that is more accurate. Yeah, there we go. So that's the last hour. So we have here is 7:36. That's when I started off. And so here we have something called the watermark. This is pretty important. Okay, so let's say this job fails, or let's say this job has some error. Like a typical error we see was the data that's coming from the device all of a sudden was in a bad format, okay, and it couldn't recognize it. So it would kind of error out, and then it wouldn't process the data, right? That was the logic, right? So, or let's say hypothetically this thing goes down. Let's say we stop it, right? So what happens is that those messages in the Event Hub, they're all queued up. Okay, so really there's kind of bit of a traffic jam. So we call this the watermark delay goes up, right? So the way I understand that terminology is that, let's say you have a like a swimming pool, okay, and it's like being filled with water, so that water level, right, is going up. So the watermark delay, so there's going to be delay in like pumping that water back out. So that watermark delay rises. And so if we see here, we don't get that monitoring details, but when I start the job up, and then I can say, okay, well, go back to the last stopped. So that's, it knows the offset or the sequence number of the event hub, and it's going to start up. It's going to take like, 30 seconds to a minute. So behind the scenes, it's probably like some kind of compute cluster or virtual machine behind the scenes, right? So this component is actually one of the more costliest, okay, because it is actually taking, CPU and memory. It is something that is one of the more costly components compared to IoT Hub and the Event Hub. Let that fire away. Okay, it's going to take some time. So here we have backlog, and we want to see the last hour. And there's the watermark delay. So I think at this point, I ran this demo just testing it out last night. So there was probably a bunch of messages that was unprocessed, and really, so the backlog was just 40 seconds worth. Okay, but if let's say this job was down for like an entire day, let's say for some reason due to some error, you can see the backlog to be like maybe 8 hours worth of data. Okay, but again, that just speaks to the whole robustness of the IoT platform in case things go wrong. Okay, things are recoverable. And okay, so yeah, that continues to fire up again. Let's see here. So these are monitoring dashboards. Okay, resource utilization in terms of how much compute you want to assign it. Where would that be here? I think it's overview. It's called the streaming unit. Let's see here. So the pricing plan, standard V2. Let's see here. It's like some streaming unit. So I think I had it as 1/3 of a streaming. So streaming unit is just their own way of describing like a collection of CPU and memory and disk and all that. Just to simplify that, instead of sorting throughout like all those cost components like disk, memory, and CPU and etc. So measured in streaming units. Let's see here. Oh yeah, scale. So in terms of scalability, the cheapest I have is 1/3 of a streaming unit, which is actually pretty sufficient in a lot of cases, especially for testing. But however, you can set it to auto scale or manual scale. And so if you notice that the resource utilization, okay, as shown here, right? If this resource utilization is spiking up to, let's say 80%, then, either auto scale or manually, okay, you can assign it to like 2/3, right? So, or one, or there's more. So if you have a higher pricing plan, then you're able to get more streaming units. So that's that. Okay, so I believe it's back up and running now. Let's go here. So as you can see here, the watermark delay, because of the backup, it was a minute and 0.17 minutes worth of processing. Okay, and so at this point, the job started up and was able to process data like really quickly. So, and then it gets back down. So your watermark delay close to 0 seconds, right, is very healthy. Now, okay, next question is, okay, well, where is that logic to process that data? What does that look like? So we have something called a query. Okay, it's very SQL-like, but at the same time, it's still very proprietary. Okay, so the main ingredients to set this up is your input. So the input here is your event hub. Okay, so it takes into account, access permissions, that managed identity I talked about, the actual resource, and identifying, okay, what kind of data format, encode it, etc. So it's reading that, and it is, you say from IoT1, which is referring to this, okay, and let's just call it gateway message, kind of like a variable. And then you're able to, take the data records and get at each data. So all I care about in this case is to get machine ID, category, the time, the unit, like inches, as we saw, and the value. Okay, for each value, what's each unit, what's that value, and the process time. So we have this line called cross apply, get array elements. So again, from each gateway message, I get the data. Okay, and it's basically expanding that array as data records. Okay, expanding that out and getting it each data field. Okay, and value. Okay, and then there's additional processing. So let's see here, cross. So all this data, as you see, machine ID, category, time, etc., is like a record, and it's stored as, or referred to as stage 0. And then I go and say, okay, well, from stage 0, okay, I parse it further. I pick out, this data, and then I store it into RKIoT machine data, right? So which is this one right here. So each one of these represent a database table, okay? So again, if I go to edit here, I'm referring to the database, okay, and database table, the table being message data, and it gets passed through there. So um, to recap here, here's the input, okay, and here is the query for that data processing logic, okay. We can see a preview of that input, like application ID, name, device use, just a sampling, right? So you can, it helps you to kind of develop and code this out, okay? And then you want to output it into specific database tables, okay? So let me pause here. Any questions on how, if you get that, the gist here, how it's processed? Okay, so really here is kind of really the meat of the whole IoT processing. Okay, and that gets directed to the database. And so let me refer to the database here. So what I do is I connect it to I'm sure all you guys know SQL Server. So I have my RKIoT database, and then I have here the machine table. Okay, and I created this beforehand to match the schema. So I got to make sure that in that stream analytics job, the outputs are, mapping to here. So the machine data, the columns, machine ID, category, time, units, value, okay, event process, UTC time, etc. So I have the machine data, and for each machine data are, the many messages, okay, as you see here, the message ID and the gateway, etc. So here I have a query, okay, so let me run that again here. So it's getting me the latest data here. Oh, okay, it's not. Okay, let me allow me to connect. Okay, it's connected. Okay, I'm gonna execute these two SQL, and I know it's probably small. I can't zoom in here, but you should see here, 2025, January 15th, 1:22 a.m. But it's UTC time. So It gets the UTC time, device ID, etc. Okay, and then in terms of the the actual like telemetry, the data is, for example, here, what's the unit, the category of the message, efficiency, dispensed, tape dispensed, are there any errors, you know, etc., cycles, etc. So we get the units and what is the value of that units. Okay, so that is the data. So this table would have like tons of records. So if you see at the bottom right here, I know it's very small, but just by querying that, I have 183,000 rows. And so in IoT, there's so much messages that you have to be careful on the data storage, and it can get very expensive. Okay, just collecting all that data, especially in SQL Server. Okay, so you have to take into account that you may want to aggregate that data, right? You don't want at a very fine grain anymore. Okay, you don't care to know. You can just have it all grouped by per day, per week. Just to get the high level patterns and then just purge the very granular data. Little tips, UTC time is very important because, hey, you want a very like standardized time reference because you don't know if a factory where you deploy the devices. First, you may think, well, you know what? They're normally going to be in EST time zone, but then a year or two, you may have a factory site or a deployment in, let's say, Chicago. And if it was local time, then it makes the processing of the logic more difficult because then you're going to be like, okay, well, if this device is in Chicago, okay, fine, you got a plus minus an hour, etc. So standardize everything in UTC, and then depending on the end user, okay, at the reporting, then you translate that to local time. Okay, so that's a pretty typical pattern. Okay, so hopefully you guys kind of get the idea and end to end. So we talked about stream analytics job. I'm not really getting into that, but it's hopefully you get the idea. Again, you can have another query, and the output is just pointing to the data lake storage. Okay, so then you go to the database. Okay, I don't have any demo or something to show, but again, as you can imagine, you just have your reporting application. It just points to the database, and you just create your reports. So there you have it. Let's see here. Any questions? So just to show again some of the monitoring here, we have here backlog. So as I stopped was a backlog. So they're pretty similar type of metrics. And then here is the resource utilization. So when as high as 40%, process that data. Resource utilization in terms of streaming unit. This is in terms of CPU, right? And event count, the output events going into the database, and any errors. So typically with errors, I would put like some kind of alerting rule saying that, hey, if an error occurred, send out an email notification with the error details. So there you have it. So I want to go back to the slide here. Talked about IoT Hub, the Event Hub, Stream Analytics job, and I'll open up for more questions. If some things weren't clear, I can go back and re-clarify.
I do have a question about what you just mentioned. I think you answered the question, but it seems to me like the value here is to be able to catch anomalies
Yep,
in a
yes.
timely fashion. So that queue or that processing where you send the email, is that how you trigger responses to errors or problems, or is there another more automated way to do that?
Yeah, okay, something like that to capture anomalies. You wouldn't use the Azure portal like as so what I just showed you, um let's say this stuff right here. Like this is just more about infrastructure management, operational, right? Infrastructure operations, right? So as long as the lights are on, um, or if you get errors, I would create alerts and send that to IT folks, okay? But in terms of business data coming from the devices and capturing anomalies, that is handled in your reporting dashboard. So that's where you would have the report developer or the reporting analyst would recognize those anomalies, those patterns, and in the reporting themselves would generate an alert going out to end users. It could be going to the support people that's maintaining those packaging machines. So it's held and managed in the reporting application, anomaly detection.
Thank you.
Yep, no problem.
All right, does anybody else have any questions or feedback? Wendy says it's fascinating. Thank you, Wendy. Appreciate that.
Yeah, thank you, Wendy. Yeah, appreciate the comment.
All right, so look, basically, this stuff looks pretty complicated, but in the right hands, as almost with everything, it can be done very efficiently. We came in from the ground up and created their platform online. And so if you have a customer who has factories and they want to collect data, please reach out to me and I'll make sure that Roy is involved with that project. All right, Roy, anything else before we go?
No, that's it. Thanks for hearing me out. Thank you, Juan, for inviting me for this talk. It's great. You guys are great.
Thank you very much, everyone. Again, if you've been listening to this on YouTube and failed to join us live, we'd love to have you next time. We meet every second Tuesday of the month. And you can find our calendar along with all the other events for Access User Groups at AccessUserGroups.org/calendar. Until next month, everybody, that's so long. Thank you very much, everybody. And thank you, Roy, for joining us tonight.
Thank you, everyone. Okay, good
Bye
night.
bye.
All right, bye.